Hello everyone, so in this video let us talk about the first three problems from the latest Lead Code weekly contest C27. So let's start. The first problem is maximum count of positive integer and negative integer. So problem statement states that you can read the problem statement, but in simple terms it states that you are given an array with some positive negatives number and some zero as well. Now you just have to find out the count of positive integers and negative integers, and whichever of them is more, which is like whichever among them is maximum, you just have to return that particular number. So in this example, as you can see that there are three negative integers and three positive integers. Answer is 3. In this example, there are three negative integers and two positive integers. Answer is 3, and so on. So you just have to count out the number of positive and negative integers and then just return the maximum count. Pretty much simple. You can just iterate over the complete array, and if you find out positive number, then increment the count of positive or negative, and then just find out the maximum of both of these values and just return. Pretty much simple, nothing much complicated here as well. So next, second problem is maximum score after applying k operations. So it states that you are given a zero index integer array nums and a integer k. Now you will start with a starting score of 0. Now you, in one operation, what you do, you will choose any index from this particular nums array and increase your score by nums of I. Whatever index you choose, take that particular number and increase your score by that, and then you replace nums of I with the seal of nums of I divided by 3. Okay, you will take the seal of it, nums of I divided by 3. So that's the whole thing. You will keep on doing this for k operations. You have to just find out your score after that. So it's pretty much simple. What you can see is that whatever number you will pick, that is added to your score, and then you'll add that number divided by 3 back again in the same array. Now because you're taking up these elements, you will be always be taking up the maximum number, because whatever is the maximum number at any given point, you will take that and then insert back. Like let's say you take x, so you will insert back x divided by 3. Okay, so pretty much simple. Now you want to just get the maximum of the complete array at any given moment of time. Okay, whatever is the maximum, and you will keep on doing it for k times. So let's take an example of this only. What you can see is that in this example you have some numbers. So in the first chance, you will always taking the maximum one, that is this 10. If you take 10, then you will insert 10 divided by 3, that is the seal of it, and it is 4. So you will insert 4 and your score is increased by 10. Now these are the numbers that is present in the array at that particular moment of time. So now you have to find out again the maximum that is among them. The maximum is 4. So you will take 4 and add 4 divided by 3 in the array again. Okay, that is the seal of it. Now this is the numbers. Now among them you will take again the next maximum, like whatever is the maximum at this given state. So 3 is present, so you will take out that 3 and then just again insert 3 divided by 3, that is 1, inside this array, and you have done 3 operations that is given to you. So you will just return the sum of them. So it's simple term, you just have to find out the maximum at any given state. In this scenario, a very simple data structure that comes very handy is priority queue, because priority queue always holds the very maximum element at the very top, that is, it is giving priority to elements. So that's it. You will just be taking help of priority queue that will do this operation automatically. For every element, you will just take out the top element of the priority queue, that is the maximum element, and then take out, add it into your score, and then reinsert in the priority queue that number divided by 3, the seal of it. Okay, that's the current particular problem and the logic for it. So what we have done is that we have created a priority queue. This priority queue in simple terms is a max heap. That is, the top element is the very maximum among all the elements present inside the priority queue. Then this is the len. Then you will insert all these elements inside the priority queue. Now you will be returning a long because you will be adding up your score, and the as you can see, this nums will be pretty much large. So what you can do is that I will insert this number converting into long so that our calculation becomes easy. Now what we'll do next is that you will iterate over all the elements in the priority queue, and you have to do this for k times. So you will doing a while loop. Now you will take out the top element of the priority queue, then increment your score by the top element, that is the maximum element, increment your score by that, and then pop out that element from that priority queue. Now what element you will reinsert? Whatever is the top element, that is this top element, okay, divided by 3, but you have to find out the seal of it. Now whenever you want to find out a floor of any number, let's say there are two things. Okay, in pretty much simple, let's say you want to find out a floor of x divided by, let's say, 3. So pretty much simple, just do x divided by 3. Okay, but if you want to find out a floor, sorry, if you want to find out the seal, like this. If you want to find out the floor, then directly just do x divided by 3. But if you want to find out the seal, then what you can do is just take x divided by 3, but just add whatever number is in the denominator minus 1 in the very top. So let's say it is 3, so just add 2. If in other terms also, if it is like, let's say x divided by any n, you want to find out its, let's say, seal of it, you will just take x plus n minus 1 divided by n. That is helpful to find out the seal, okay, of this number. And pretty much simple. Why this is helping? Because now you are adding a buffer of n minus 1, so that even if there are some numbers that are left, you will be taking them in the next chance, so that it is acting as a seal. Okay, that's the overall logic that you have to use now. And then you will just insert this particular number divided by 3, seal of it in back inside the particle that is pushing it back, and you will keep on doing this operation for k times. In the end, you have your total score. You will just print out a total score. Pretty much simple. That's the correct logic for the second problem as well. Moving down to the third problem, it states that, or the problem name is make number of distinct characters equal. It states that you are given a 0 index string word 1 and word 2. Now what you'll do is that in one move, the one move consisting of taking two indexes I and j, such that I is indexed on the word 1 and j is on the index on word 2. So there are two words, okay, and then you will choose one index on each of these words, and then you swap the ith character on that particular index. Okay, so you will just have two words. You will, in simple terms, there you have two words. You will just take one character from the first string and one character from the second string and swap them. Okay, now what you actually have to return is that, is it possible, you will return true if it is possible to get the same number of distinct characters in word 1 and word 2 if they're equal in exactly one move. So in just exactly one, let's say, swap, you have to somehow get the different number or distinct number of characters in word 1 and word 2 to be same. Pretty much simple. That's the current thing. If you are able to do this and exactly one, you have to do exactly one operation to swap one character from the word 1 and word 2. Okay, and then in the end, you just want to make the total number of distinct characters in word 1 and word 2 to be same. Okay, that's the overall problem statement. Now, because the constraints are pretty large, you cannot do this in a very brute force way, just swapping every possible pair in word 1 and word 2. But the overall thing is that even though the different number of characters are like the length of this word 1 and word 2 are very large, but what you can observe is that the total length of characters, like the total number of characters possible, is 26 only. And thus what you can do is that, let's see small example. Let's say that I have a c as word 1, and let's say word 2 is b, okay, and let's say c. Now what you can see is that if I swap this A with this C, or this A with this C, or this A with this C, these all are same. Why? Because swapping these, like any of these A are similar, because I'm just swapping a character. So why not just group all of them into one? I hope you get the point. And thus what you can do is that you can find out the frequency map of the word 1 characters and the frequency map of the word 2 characters. All the characters in word 1 and all the characters in word 2, you will find out the frequency map, so that you have now only an array of 26 size, like this. And then on that array of 26 size, now you can do in a very brute force way. By brute force way, I mean that I will exchange, let's say, any A with all the characters present in the other string. Okay, you will try to exchange any, like let's say I want to exchange A with other string, and then when you exchange them, you have two frequency arrays that is of size 26 only, and you just have to find out that whether the different number of characters present in both of these strings are same or not. That can be also done in a very simple manner, because it's 26, it's very small, and thus you can do this in a very easy time constraints, and that's the overall solution that we will be using out. Let's move on to the code part, and then you will understand more clearly. So what we have done here is that we have first created a frequency map, that is ch1 and ch2, for both of these strings. Iterate over both of these strings one by one, and then find out the frequency of every character and update it inside this frequency map. Now you have the frequency map of 26 characters of both the strings. Now what you'll do is, now you will find out every possible pair. Okay, every possible pair. Let's say two nested for loops, one for the first string and other for the second string. And now what you'll do is that you will exchange, let's say, a type A character with type C characters. Okay, from the type A character from the first string and type C character from the second string. The only condition is that both of these characters should present in that string. Okay, so what you will do is that if the frequency of the ith character in the string 1 and the jth character in the string 2, if they both are greater than 0, which means that frequency is greater than positive, what you will do, now you will take one occurrence of that particular character and insert it. So let's say you have, let's say AAAB and let's say AAAC, which boils down to that I have, let's say A 3 times, B 1 time, and here A, let's say 3 times, and C 1 time. Now what you can do is that I can, this is the actual string. Okay, now I don't think about the string, but if I want to swap A and C, one occurrence of A in the first string and one occurrence of C in the second string, what I'm eventually actually doing is that decrease this frequency by 1, it will become 2, increase this frequency, like because I'm swapping this out, so this is taking it out, like I'm taking out A from this string, so its frequency is decreased by 1. But similarly, I'm putting it inside this string, so this frequency increased by 1. Whatever is this character in the other string, it is increased by 1. Similarly, I'm decreasing C from this string, so this will decrease by 1. But similarly, in this string, I will increase the C by 1. I hope you get the point. That is the overall idea. So you will take in the first string whatever ith character you are removing. So remove its occurrence by 1 and increase, as you can see, the same character, okay, in the other string. And similarly, the character that I'm removing from the second string, okay, that you have to remove in the second string and increase its frequency in the first string. So that's the overall idea that you have to do. Now this is one of the operations that you have done. Okay, now you have removed this or like interchange this characters, okay, of this type. Now you just have to check that whether after doing one operation, like whether both of these strings has now the same number of distinct characters. Now for this you just have to write down the check function. It's very simple because these are just small length arrays of size 26, so you can directly just do it in a very fast manner, and thus it will just check that whether it is possible, so you will return true that it is possible. Okay, now the one more catch is that you have now swapped this particular thing in the array itself. Now you have now changed to a new string. So your original string was this, and you want to change, let's say A with A with C, A with B, or whatever string you have. But now you have changed the string by doing this operation, and thus you have to make your string to the original string so that you will now do it more operations or different number of operations. So you have whatever operations or whatever, let's say increment or decrement you have done here, just reverse it after this check, because now you have taken one pair and you have changed it according to this pair, you have checked it for this pair. Now you have to backtrack or like you can say reverse your changes so that for the next pair you will do the same thing. And thus it's pretty much simple. These are all O of 1 operations, so nothing to worry about. And what you have done in this particular function is that in this function you have to just take and find out number of different characters in both of these like arrays, okay, of size 26. So you will find out different type of characters. So you will just make two variables, iterate over the complete, let's say, array of size 26, and how many type of characters are present is denoted by the different number of array that are like the cells that are present inside the array that are greater than 0, which means that, like, let's say A is present 5 times, which means that A is a distant characters. Okay, so I just increment your count by 1 if you find out any let's say block inside this array greater than 0. Okay, you will do the same for both of these, let's say, arrays. And the end, if the different number of distant characters in both the arrays is turns out to be same, then it will return true, else it will return false. And thus in the end, if you find out for any swap that this is true, you will directly return true that I have found out one of the answers. And for every possible pair you cannot find an answer, then the answer is false. Okay, so what you can understand from here is that even though the larger strings are larger, the original strings are larger, and you cannot do brute force on that, but you can compress that particular information into smaller let's say chunk, and then you can do brute force on that. Okay, and thus it becomes very simple then, and that's all logic in the code part for all the three problems. If you still have any doubts, you can mention in the comment box of this particular problem. I will see you in the next day coding, and bye.